In this video, we will learn how to check for misalignment between couplings using the straight edge and feeler gauge method. This method is not known for the accuracy of its readings and is used to get a rough alignment only. Here are the main steps followed in the straight edge method. Make sure the base plate is clean and stable. Check runout for both driven and driver shafts. Check both these shafts for soft foot. Bolt the driven unit. Check runout on the mounted coupling halves. The angular and parallel misalignment is then checked and corrected in both the vertical and horizontal planes. Let us see how that is done. We begin by ascertaining the vertical angular misalignment. Using a caliper, measure the total gap between the two couplings with the chalk marks on the coupling hubs defining the 0 degrees position of the shaft rotation for this procedure. Then rotate so chalk lines are at 180 degrees and perform the same measurement check at the new location of the chalk lines. Subtracting the value obtained at 180 degrees chalk line location from the value obtained when the line was at 0 degrees. This will give you the vertical angular misalignment. A negative value means that the top gap is smaller than the bottom gap and requires the front of the motor foot to be shimmed. If the value is positive, then the top gap is larger than the bottom and the back of the motor foot requires shimming. The next step in correcting vertical angular misalignment is to shim the motor, so the shim thickness must be calculated. 2 additional measurements are needed. Use a caliper to measure the coupling diameter and the distance between the motor mounts. Calculate the shim ratio and the required shim thickness. Remember to use the absolute value of the vertical misalignment. The shims should be placed under the front feet of the motor if the vertical misalignment is positive. Negative vertical misalignment means the shims should be placed under the rear feet of the motor. Next, we will determine and correct for the vertical parallel misalignment. This process assumes the couplings are the same diameter. Rotate the coupling chalk marks to the 0 degrees position. Place a straight edge ruler on the chalk marks. While holding the ruler firmly at the higher coupling hub, use a feeler gauge to tightly fit the gap between the other coupling hub and the ruler. Repeat these steps with the chalk marks positioned at 180 degrees. If this value matches the value at 0 degrees, this will be the thickness of shims you will need. If the values are different, the average of the two values will determine the thickness of shims to be used. Shims should be placed under all 4 feet of the motor. The horizontal and vertical angular alignments differ in only one aspect. The gap measurements are taken in the horizontal plane at the sides of coupling halves. Here, the chalk marks positioned at 90 degrees and 270 degrees ascertain the horizontal angular misalignment. However, this misalignment is corrected by adjusting the motor by pivoting the rear or front of the motor to change the angle relative to the driven shaft. After calculating the horizontal angular misalignment, loosen the motor mounting bolts to adjust the motor position. Slide the motor so that the coupling gap and the angular misalignment difference between caliper readings at 90 and 270 degrees are within the allowable operating specifications of the coupling being used. Perform the check at 90 degrees and 270 degrees to ascertain the horizontal parallel misalignment. However, this misalignment is corrected by adjusting the entire motor equal amounts front and back, perpendicular to the axis of the driven shaft. Rotate the hubs so that the chalk marks are on 90 degree first and then to 270 degrees, and check misalignment again. If the measurements are the same, then this is the amount of shift you need. If they are slightly different, then take an average of the two to determine the amount of shift. You need to move the motor in the direction needed to correct the misalignment. At the end of each alignment, repeat the steps to ensure that the couplings are aligned. There may be some allowable misalignment for different coupling types. Check with the manufacturer to be sure.